team and Miguel, of course, for organizing this event where we will hopefully have this wonderful dialogue of cultures, European culture and Oriental culture meeting today and hopefully coming up with something new. I want also to thank those who will contribute today. I know that there are some contributors like Ali Avicenna from the Clean Production Center, and today had Dr. Rashad Foli, our Dean of the Faculty of Engineering. Of course, Martin Holler from the Austrian Embassy, the commercial attaché, who is a very dear friend to us, because the Austrian-Egyptian relationships with Sekin is a very obvious one, of course. But also Dr. Hind, who will contribute here a little bit later on what the housing ministry is doing in this regard. Most welcome. And I don't know, I think only Marcus and is now out, right? The only one who is still on the list. Now, what's the objective of today? This is the Solar Tunnel Conference, as Fredrik has mentioned, and I obviously thought, what is it going to be about? One is that we are very happy as SECAN, with the support of the Austrian Development Agency, SECAN Energy, and partners in Austria, were able to learn a lot about solar water heaters, and we will get a presentation where Fredrik and the team will present what we have learned over the last 2 weeks and months on the topic solar water heating and what our company Eco Energy can hope to provide the services to the market and is working on to developing. But this is the one thing. The other thing is that we, over the last few weeks and months, even years, because we are working now since several years on the project in Egypt, have met many partners, many stakeholders of solar water heating in Egypt. Those from the private sector, like CALIT and associations of those in the industry and private sector, hopefully represented here, but also government associations, institutions from INREA and all the other institutions. And there are a lot, both in solar water heating and renewable energy, and then obviously the universities and research institutions, like the local university, but many others we have met over the last 2 years. So we have partly regulators, research, education, training, and industry representatives on the table. And the question is, how can we optimize this cooperation between all the players and stakeholders to make sure that finally solar water heating and renewable energy in large is going to take off in Egypt. Why I'm saying this, whereas at least in the news it's every day that it's taking off in Egypt. First, we shouldn't forget that solar water heaters is in the making since 120 years ago. I think somewhere 1896 the first solar water heaters were built in Europe. And we should also forget that about 100 years ago, the first solar plant, major solar plant in the world has been set up in Mali here in the Bakshuman, I think was the name, did this great endeavor 100 years ago, 100, actually 3 years ago. So it's an old thing. And then it went very flat for 50, 60 years. And it needed back basically oil prices in the 70s to take off much more. Today, there are few countries like Israel, Cyprus, and Greece who have more than 30-40% of solar water heating installed already. There are huge capacities in China and the EU and the US. And in the UE, I was happy to see that particular Austria is a big capacity for a country which is not at least as much as we in the desert or in a different form of desert. This is a great thing to happen. And in comparison to what is the capacity still installed in Egypt, we, I think, have a lot of potential to develop. what we are all aiming for. It makes sense. It's visible. It's getting more and more visible. There is a need, and Egypt is also oil prices are low at the moment, but nobody in the world is really expecting that oil prices will stay low for a long term. And Egypt is not largely a producer of energy anymore, or not expecting a lot of oil and gas anymore. So for us, it makes a lot of sense to rely on renewable energy. So our objective is to see what we can learn from each other, how we can combine our forces, what synergies lies really in this stakeholder conference today, to see what we can do to contribute to more solar energy and more renewable energy. This is the objective of this meeting today, and I wish you all an inspiring meeting, and look forward to a lot of new information and hopefully also some new initiatives coming out of this conference. Further initiatives to do more. And yeah, once more welcome, and let's leave the event to Birgit to take over and give us the idea of the project. Thank you very much.
based on the southern Austrian part, Syria, and near the capital there, it's the end of Graz, where we also have this research institute in Graz, Graz University of Technology, which we are cooperating. Yeah, and we decide our Austrian activities, which are the next slide. More point. And we see each other, especially for tasks in Egypt, like the bridge between Austria and Egypt. So we have, as you see on the map, we're not, like Mr. Helmi said, I'm very comfortable with these words. Thank you for this. You see that this is nearly or just like half the solar irradiation in Austria, like in Egypt. But what we can offer Egypt, why we are doing this as Austria, the small tiny country in Europe. Austria not only has a big content of solar water heaters, it's the most installed collector surface per inhabitant. So we especially also like renewable energies concerning. We having like 70% and much higher content of renewable energies. We yeah, do our energy and produce our energy in Austria, and therefore we have to bring a lot on the table. And especially solar water heaters, we also have big economies in Austria. And exactly, yeah. And we see us like renewable energies ambassadors and just can initiate ideas in Egypt and to initiate like awareness to build up also a sustainable way of solar water heating development in Egypt. So, and that leads us to our mission. Like I said, it's our priority to see solar thermal energy as a key element for sustainable heating. And especially Egypt has enjoys very much highly solar irradiation, and we have like technology and know-how, and we can do our mission is to implement this or to lead this natural resource to business and to economy development. Yeah. Exactly. So, what we do? We work in the field. So, Taking Energy is an Austrian company, and we are very much in taking Egypt. And therefore, that's the reason why we go to Egypt. Otherwise, we would not come to Egypt, I think, because it's so partnership with different. So, and in Austria, we are working in the field of renewable energy since more than 15 years. And those are our shareholders in different technologies. Some of our shareholders work for 25 years in the field of biomass fertilization, and also we work especially in our field of solar cooling and so on. And you see, the first step, in our opinion, is how could we save the energy demand? And the second step is always to use it with sustainable solutions, with system coordination of renewable energy installation. And we discussed in certain information what we are going to do. Actually, the last one, the red one, is not project from our side, but we also use this car very often when we go to the town. So it's not our car at the moment, but maybe in 20 years. It's the Tesla car we use for the electrical. We discussed why not to make a project e-mobility here, but I think this is I think what Europe can learn from Egypt. The traffic here is quite efficient. When you see the people, the amount of people in cars or the amount of weight in cars, yeah. But it could be one solution, the electric one. Yes. So these are our partnerships. I think also the American University of China and that's the main regional partners. And we have also partner consortium in Austria. This is the company Greenwaldec. Greenwaldec is one of the biggest solar thermal collector production units in the world. And it is very funny because nobody knows that a lot of collectors coming from Austria, from Germany, only coming from Austria. They are just level from different companies now together. It's a company in Carinthia, and they help us to build up here in this project a local collector production unit. This is Greenwaldec, and one of our partners is the company Paving. And this company is more focused and related with the field of solar cooling and including energy storage tanks. And the other company is the special engineers of the Mr. Martin Reichel, who is here. He is the installer and the constructor, and has been already installed a lot, a huge amount of solar thermal collectors around the world, and also in China, because Austrian knowledge is also important in China, very interesting. And one of our partners in the field of training and education is the BFI from Nuremberg, and they help us in doing the certifications for training. During our effort in Egypt, we also built up training programs for some of the companies. And these will also be here in contact. Thank you very much for your attention.
Exactly. And like also Mr. Henry said, our network in Egypt grows and develops with our time through all the last years, and we gained a lot of experience, and also together with our partners on the journey. So that brings us to our activities in Egypt, which I want to start at the very beginning. Like phase one, our first approach on the whole solar water business in Egypt. Here we have in phase one to the aim to target more an industrial purpose of solar water heating and go more into large scale plants, but as well like for industry and tourism especially also as well. And we see the potential that there are a lot of products on the market, but not very, they're not fitted to this market. So it's a very unnatural or very hard surrounding for solar collectors with the heat. It's double than Austria, for example, double than Europe. So you need a special product for this market. And therefore, we developed together with our Austrian partner, Greenwaldec, a solar collector, which fulfills all needs and all requirements needed for this region.
Because in the first next week, we have a look and check what is going on here in the field of solar thermal production. How does the business work? Where are the problems at the moment? Because I couldn't understand why was a section not using solar thermal energy, because it's their proven technology. And therefore we found out there are different conditions here, and the producer delivering you this solar thermal component, they didn't proceed with this special conditions under Egyptian partner. Exactly, the very strict topic. So we found out there are a lot of collectors installed, but it was the coating inside which bad, or only outside. It was coated inside. And that's the reason because the collectors are open. Usually the collectors in Europe are more than one outside. That's the region they have a long space, an open space, that the air can breathe and the air can come in. But that's a big problem here in Egypt. Therefore, and that's also one point what Greenwaldec found out, that it is necessary to adapt the systems or to adapt the components to these conditions. And that was one of the strongest and biggest efforts in the first phase of our project.
Exactly. And we had to do some tests as well and some purpose of this collector for tourism. There was with the cooperation of Sequent to use this energy and to try how we can find a solution for industrial purpose and how to adapt this system to install heating system in the food industry.
At the beginning of our presentation, we saw one slide that was exactly the first plant we installed in Denmark.
Exactly, yeah. And you see it here, like the glance, it's also like our monitoring. You see this picture as well online.
We check compost, yeah? If they just work a lot.
Exactly, yeah. If they clean the panels once a week or not. So it's like a big part, a partnership between. And with online monitoring, this allows us to cooperate always or to see if it's working, if there is failure, yeah, exactly, yeah. But also on this in this phase one, we see some potential. It was our idea also to make like somehow a knowledge transfer and do this plant also with local added value to add local added value on this. So we made like a maintenance training and we trained Egyptian workers and technicians in installing such plants and maintenance this plant. And this maintenance training got implemented then at the vocational training center, which is basically a base in the city of Paving. So, and this is like the sustainable approach of this project that we have now also technicians local there who can maintenance this plant. Otherwise, it wouldn't be sustainable.
And we also found out it is necessary to implement this knowledge in the schools on different levels. So we implemented in the vocational training schools and we also implemented on a higher level. We did curriculum for example, energy and technology schools at the higher level. But now in the new project, these are made in the new project.
So this is how our project now looks. And it's yeah, an industrial purpose of solar water heating there on the second part. And it's delivering preheated water to a steam generator, which is like a surface of 40 square meters. And the system design and installation come mainly from Austria, but were trained also then the local people were trained in installing this and maintenance this especially. And it was in collaboration, the whole training with synchronization with the center. So what we see there was our training and the mounting and the hands-on workshops and everything. And we already gained, I think, a lot of experience through these installations. And also seen like there are some metal parts from these collectors which we have to bring, or which we had to bring first from Austria, but we see why this we can't make produce in Egypt because maybe it needs more technicians in welders. So the idea was also then to implement maybe a welding workshop or a welding training. This was a step, the follow-up of this phase one from the solar project to lead to a welding project.
And we have also the experience of welding in Austria as a company Knowledge, because Knowledge, we discussed that with Knowledge, we see the big potential for welding, and so we're starting up welding.
Yeah, and after this phase one and the welding project, parallel, we developed or think about how we can move on, move further. And this exactly, yeah. And we've seen there a lot of potential also in a sustainable way, to provide a sustainable way. It needs training of people and in different kinds of communities, not only a university, not only vocational training center, also adult educating, and to implement such trainings in yeah, in schools and universities and yeah, exactly.
There would be created a new job profile with the Austrian training organization. We have called Egyptian solar thermal engineer. And within our last 3 years, we did training for about 20 to 25 persons. And that's called the solar training trainer also in thermalization.
By the way, we are really looking forward because we're really looking forward to for tomorrow. There is the last exam of this training, which all took place here in Mediopolis University, and a lot of different people, PAs from Mediopolis University, also from the UCA, and yeah, WEAA is also attending this training, and also like other research facilities in the sea, for example. We're really looking forward to finalize this training tomorrow with the exam. In this phase, we also like want to target not just the private sector, but more on smaller scale, downscale the system, more basics, also small systems. Let's develop small systems, and therefore we target more the residential sector and tourism sector, but still going through the way to industrial processes.
And that leads us also to that point that we see we start with the collector production now in England, and it's running. It's great to see that. Everything is running. Some people from Paving was trained in Austria in the name of the company. And now the next step is also that we want to really see, and we're taking with our partner how it is working. The exactly that you don't make step by step, but if it's moving forward, you have behind in your mind that it is a quality good. So it's always necessary to check the quality, check the materials and so on.
Yeah. And further, especially when we're dealing with the private sector, it also leads us to implement, for example, financial instruments. So therefore we cooperate with the Austrian Development Bank and CIB, that is still under the construction. What you see here is our training. It was a combination of practical trainings and theoretical training parts. You see, we developed a small demo plant, which really function like a big solar thermal water heating plant, and where we can do a lot of tests and system dimension tests and running tests and mode function tests. And we're very happy to have these pictures. They are very new, they come from yesterday. It's like a successful outcome of this training of the trainers. Because our colleague Marcus yesterday had the chance to visit some central plants which are installed on residential housing in Sadat, definitely. We're very happy to also have Dr. Hens here for a presentation. But the responsible people of Nuka, for example, there in this place will attend our training. Yeah, as we told, it was like a big part to adapt systems on the Egyptian market and also like to test these systems under Egyptian sun and always gaining experience. And through this experience, also always try to be as much and develop as much with local high added value. So we had the idea to instead of importing the whole system of the collector, to installing a collector manufacturing here in Italy.
We will only remain the necessary point amount to operate with the clean side, it's called absorbers. And the absorbers are very thin. The absorbers have a high technology product. So our intention is only to bring the necessary points from Austria, and the rest we can
Yeah. So our long-term goal is also like to develop a thermocycling system here local.
And that leads us to this slide, and you can see on here, if you take in general the cost for solar thermal systems, not for thermocycling systems, but for more larger systems, like we had it on the solar, like we had it on the farm system side. In general, you can say about 50% of system costs are for manpower, and then about 40% for material costs. And the same for the people. And in this case, we have to pay about around 11% for transport costs. No? And therefore, our efforts go to bring, to make strong partnerships, to reduce this point that depends on manpower, that we can implement more people from the shipping side in building up such systems, and also from that point, right? Because when we bring collectors and load people into Manila from Europe, we can increase the added value from both sides, from material side and also from the manpower.
Yes.
On the bottom, you see here the different points. You see, it is necessary if you come to the selling point, you need someone who is able to make the sales organization. The next point is to make the raw concept and the detailed concept, and then the integration and the optimization and design maintenance. And along through this chain, we need people, we need partnerships, and only if we can build up along through this chain partnerships with the companies, in our opinion, to build up good sustainable solutions.
So indeed, this leads us again to our mission and to our way, like we see in the past 6 years, and what we see and what we learn, our experience, and bring this experience more into not a vision, it's more a mission now, to work and implement these systems and have the way of paving the way, a sustainable way for solar water heating here in Egypt. And therefore, we also gained a lot of experience, and we learned to know a lot of institutions that we're very happy about to cooperate with them. And as we are all here today, I see this, especially like if we are here on our conference, I see we have like this bunch of expertise already. But let us discuss more needs and ideas together. Maybe we'll use the conference and develop together solutions, and which leads us to actions together. Yeah?
And the new ways and the new forms of cooperation.
Exactly. Yeah? And therefore, I think when we push our efforts together, we can pave a sustainable way for solar thermal unity. So, thank you very much for your attention.
Thank you very much.
Thank you very much. I think that was very enlightening and very interesting on how we can start to use solar thermal energy, and as we all know, it's an incredible resource that is very much untapped in Egypt. To build on this, and in order to see exactly how this can be applied, I want to introduce up to the stand Mr. Ali Abu Sinna, who is the director of the EMCPC here in Egypt.
side, I have to go back for the beginning of the Zero Production Center to mention the first Mr. Hilma Braish, which was one of our steering committee members helping this center to set up at the university. So I will just give overview about the center, our services, the projects in general, and focus on the solar thermal application, and then come to the. So our center has been established by the Ministry of Industry, in close cooperation with NIDO. We are part now of mineral production centers network of 51 mineral production center in Europe, Africa, Latin America, Eastern Europe. We have one in Austria. We were being established with the support for the Swiss government and the Austrian government and also contribution from the Egyptian government. We have been established as a center of excellence and service provider for the Egyptian industry to ensure its sustainability. So our vision to be a center of excellence that helping in promotion of green investment, resource efficiency, and greener production. At this time, when we started in 2005, it was a big challenge for the center to be working integrated with a huge subsidy resources, water, energy, and others. And I think after the crisis of the last 2 years of energy, we will be in more positioning ourselves to help the Egyptian industry. So our mission, how to promote resource efficiency, greener production, green technologies, tools, research, and the practices to the Egyptian industry. So I will not go for all the services, but our main service is technical assistance in the resource efficiency and greener production. In a nutshell, greener production and resource efficiency, how to minimize the input from raw material, energy, water, to reduce the consumption, the output of your product. For example, if you are producing 1 kilogram of water, sorry, of white cheese. So in Egypt, currently, we are using around from 8 to 11 liters per 1 kilo. The normal and the international benchmark is around 4 to 5 liters per kilogram. So you can imagine how much of resources that we are wasting, which are affecting on our competitiveness, we are affecting on sustainability of our industry. So from this perspective, we try to help our industry in different areas. One of them, of course, that we are working towards energy efficiency and the renewable energy application. And in this term, I think it's very important to always link between energy efficiency and renewable energy application as a step for providing more efficient energy. Of course, we have other activities related to chemical, to industrial waste. We are not giving financial support, but we are helping the companies to access to the financing packages. We are also doing some projects on national and also some regional projects and international projects through our network. So we have been established as a part of the Industrial Council for Technology and Innovation. We have other centers, are sector specialized, but we are a cross-cutting center among other it's our big network, we have a congress every 2 years, we change its civilians, and we have a lot of collaboration with different countries in this activity. Just quickly about it, because we have in the last 4 years, center has been growing with different projects in different areas related to the services that we are giving. For example, the one I will more highlighting in my presentation, the utilization of solar energy for industrial process heat and focusing on food, textile, chemical industry, and we try to apply our integrated approach, starting from setting up some incentives and policies and working on local manufacturing, training, and also demonstration. And also we have also innovative financing scheme to promote solar heating application in the industry in Egypt. Of course, we have another project related to waste exchange. It's the first waste stock market we try to develop in Egypt for the industrial waste in Egypt, and we have it with collaboration with the African Development Bank. Also, we have in the area of energy, we have a program with the International Finance Corporation with the efficient electrical motors. We try to have a standard for this efficient electrical motors in Egypt and also helping in the energy efficiency for electrical motors in the industry. So it's also around $6 million project. Also another project with UNIDO on the promoting environmental science technologies in the Mediterranean countries mentioned and involved in it, focusing on promotion of resource efficiency and cleaner production in food and chemical industry. Also have a project with UNIDO and Ministry of Foreign Affairs in Japan. It's one of its first time in Egypt in working adaptation, climate adaptation, rather than on prevention, that we try to think ahead if there is a shortage in water and energy, how our industry can be adapted with this, and we are presenting it in four countries: Egypt, South Africa, Senegal, and in addition to other projects with I2C, we try to work on benchmarking based on the experience we did over the last 10 years. We try to benchmark our industry based on the audits we did. We try to see for food, for textile, for chemical, based on the audits we did to highlight where is the area that we have to focus in the next 5 to 10 years that can be added value for the Egyptian industry. It's very interesting industry related with IBC. Of course, also I'm working on a regional project. We are leading it in Ethiopia, Uganda, Tanzania, with support from the African Union that's working on promotion of renewable energy for these countries and focusing mainly on linking the research and development in the universities with the industry needs, and we small medium euro projects that we are already running. Currently also working with the EBRD with drafting and putting this what we call roadmap for new carbon technology in the cement industry. It's actually a bilateral collaboration between the cement association and the our soldiers in this industry to try to come together with a voluntary roadmap how we can really more efficient and low carbon intensive industry, especially in the cement industry, which has a lot of implication after the switching to coal and other things. This is just briefly about our partners that we have been developed over the last years. We have local partners like the European Integration Industry, international moving initiative led by the USA, African Development Bank. They are just focus on this project. It's really very important. That's why we are very interested to see how we can really synergize and work together on this area. So our project, as I mentioned, is utilization of solar energy for industrial process heat. Why industrial process heat? Actually, we were preparing for this project. We were calculating that at least 40% the 50% of the electricity used in the industry, specifically in food and chemical and textile, is going to the heating electricity. This is the experience also we learned from other countries like in Austria three sectors are the main sectors that are highly needed for this heating processes, and this including, of course, the drying process. So, objective of the project that we try to create the demand for this type of solar heating application in the industry. Uh, we were having a lot of experience before in the housing industry or in the housing field, but for the industrial sector application for solar heating, it's really a quite challenging in Egypt. So after the crisis of energy, there was many requests from companies, especially in the food or chemical side. How can I have like a backup system for using solar heating application in the heating processes? So this is why we will our objective to promote local nutrition in this industry, try to work on creation of jobs and also developing some type of standards and certification scheme for this technology in the field. So the project components that we have already, four components. First one, the policy component that we try to create some incentive for this type of technology in Egypt. And we have now a very, very important exercise that we are doing with Fraunhofer Institute, BSA, that we try to develop a roadmap for this project based on the international experience and what is the current situation. What does it mean, roadmap? We try to identify what are the subsectors that we have to focus on the three sectors I mentioned, food, chemical, and textile. What are the types of technology that we have to go for? Shall we go for flat plate? Shall we go for CCD? Shall we go for vacuum tube? And what is the feasibility for this to be according to the distribution in our factories? And what type of temperature that we need in our industry? Shall we go, for example, for low temperature and we will continue with conventional energy? This is most feasible for Egypt or not? So the roadmap try to also to put and concrete target for us, because in this project we aim to have 100 pilot projects in the green industrial sectors. So this roadmap also tries to help us how we can calculate the feasibility for this project to be implemented. So under this policy component, we try to make it clear what type of incentives that we can push through the Ministry of Industry, through other ministries, through the demanding ministry to work on our promotion of solar heating applications. We have another technical component, and this is very important one, because when we were preparing our project document, we defined that Egypt is lacking expertise in designing of the system, even in the university. To put it very clearly, that this is very missing in our universities. We have it theoretically, but once you come to the, especially for the large systems, that there is no competencies in Egypt in this area. So we work, for example, in this project with Austria, with the Sustainable Energy Institute, to help us with putting this technical training for experts from industry, from universities, from individuals that have to learn this industrial designing for such system, and also coach them with the pilot project that we have the theoretical and also the practical one. And also this is related to promotion the local manufacturing, how this can be in Egypt manufactured and be supplying for the Egyptian market, and not only for the Egyptian market, but also for the we have also capacity building and raising awareness. And also we have a very important component from the $6.5 million we were successful with ships that we get $2 million as seed money with the International Bank of Egypt that we can help to support with a very mild interest, providing projects or demonstration projects that we will select during this expo. So, in a nutshell, that's what are the expected results of this 5 years project? We try to design the synthesis between impulses to promote this local manufacturing of this industry. Then working on demonstration of pilot projects for using solar thermal technology based on the roadmap that we will finalize it in 2 months and we will announce it in a workshop at the results. What type of technology that Egypt has to focus on? Because human, as I mentioned, that when there is such to work on the CCP, it is very expensive. The effectiveness of it and is not that much. And if we go for other technologies, what is the best technology that we can work on this 100 pilot project? As I mentioned, as you were mentioning in the presentation, training of technicians and engineers in this area is very important in Egypt. You know, now, for example, by the law, the new electricity law, there is mandatory for all companies that consuming for more than 500 kilowatt that we have to have energy manager. Yeah, we have to have at least someone who will understand the energy management training. So this is an opportunity for job that we also focusing in this project on engineering and also the technician part. Of course, one of the integrated issue for us is working with EOS and Maria to work on the standard specification for the manufacturing, installation, and the operation and testing of this type. Of course, I have my colleague, we have Maria, our main partner for this project. We will be part of this work to work on the testing procedure and with some equipment to fulfill rather than inside Maria itself. And this is one of the output of this project. And as I mentioned, this we have this also financing scheme that we are now calling many donors to contribute to enlarge this $2 million, especially for solar testing application. So this is in general our partners that I mentioned in area, and of course we have the OES for the standards part. Our film production center is project management unit that we are leading this project in cooperation with so the last thing I would like to say that now we are finalizing this project, finalizing the roadmap that we will put very clearly for us our target, but we are focusing on a very integrated approach to help and implement this project, focusing on policy, standards, testing, training, demonstration, and also having a scheme for innovative financing for such a type of well, with this, I would like to end up about our main goal for this Neo Production Center. We try to work on implementing principles and embassies, productivity, competitiveness. We also try to transfer this knowledge, and that's why we are cooperating with different international and national institutes to exchange this experience. I hope this is not too much. And thank you very much again for inviting us for this important work. Thank you.
Thank you, Mr. Ali. I have to admit, seeing initiatives like these happening in Egypt and being done at this level, it's something that's really wonderful and something that gives someone hope that for the future of Egypt, honestly. Shift results there. Thank you so much. Right, now, coming up next will be our very own Professor Rasha Al-Huli, who will be dealing with our own applications, our own innovations at Heliopolis University in terms of solar water heating. and discussing the interrelationship between energy, water, and perhaps even food in the aspect of solar energy and what we are doing. Thank you.
A very good morning to you. I'm trying to look from a different perspective at what we're talking about today. I understand that we all gathered here with the overall goal of sustainable development. We're targeting a greener environment and a green economy. So since we're all talking with respect to one goal, I will try to look at the dimension of the education and research and the link to the practical work and industry. This is our main goal at the Yafis University and specifically at the Faculty of Engineering. So the presentation is about the applied research, the practical education, and the know-how, and how this is related to what Birgit was saying this morning, that we need to see it on the ground. That's what we're trying to do. So starting with the safe training that Birgit was talking about, that was implemented within Heliopolis University campus or within Seacom Farm, the TLT for the solar heating in Egypt. And that was conducted in 3 phases. The first was in September 2014 for the teaching assistants to be trained as the catalyst for the upcoming trainings, whether in Heliopolis University or extended elsewhere. And that was for the basis of the thermodynamics and the calculations of fans, followed by another training, each for a whole week, full day, in February 2015 to understand the different components of the solar thermal heaters. And the third training in September 2015 for the overall know-how and real implementation, where you have seen the solar thermals done by our engineers. So that was some photos taken on the ground from the first CFP phase 1. Phase 2 was hot water coming from the system and the demo system that's available inside our campus. And the final phase, the professional one on the know-how. So this was on for the teaching assistants, and they got trained, certified to develop and transfer the knowledge. But this did not stop on the level of having a very advanced training, but it was transferred to our curricula. Our curricula, which is mainly designed to as a hub for new technologies and new development to take place. So there was a curricula upgrade in 2014 to adapt what we're up to, and that went to the Solar Thermal Energy Systems course, and these are the codes and implemented course, and the Renewable Energy Applications, and these are main courses with 4 credit hours each in the program of energy, which is following the electromechanical department. And it is proposed to take part of the graduation project that actually came from some students who are present today. These are the projects I'm trying to list that these were implemented and how they were distributed over the weeks that the students get to do the assembly and select the parts, buy them and put them together in an actual demo. And students were divided into 2 groups to have 2 different projects based on what they have learned as practical part of the course, which has, of course, the theories, the theoretical part, but this was the implementation that was supported by the engineers, the teaching assistants who had training on that program. These are a production of the group 1, very primitive equipment and tools that they built themselves, they worked on, and they developed to produce what we produce. The days that they were working on the workshop, trying to develop a very primitive example of what they have learned in the course. Another production, and where they were trying to develop, and the way they presented even junior students. But that was not only where we stopped. We're trying to extend the knowledge to projects, running projects. And if you have time today, you're more than welcome to have a tour in our green campus to see some of these projects, where some of them have pilots implemented within the campus and others are outside the campus. We have many projects, and actually there are more others. The Trinex, the Water Food Energy Nexus project, where it has a pilot. The groundwater solar pumping, and that's in Wahat. And the surface water pumping in the Delta, which is our new baby that's having a workshop next week, the first workshop on using it for surface water, because we had an experience using it for groundwater. The Children University, a very unique experience that the Yafis University is leading. And this time we have the knowledge transfer from the students, who have the knowledge from the TAs. And the business incubator, which is the hub that's open for all startups. These are the panels that we have, new types of solar panels that build the greenhouse. And this greenhouse is linked to reverse osmosis desalinating the brackish water, and this brackish water is passed into pockets of fish and lecithin sometimes. So that's the whole system of having the water, food, and energy linked together with the know-how of using unconventional water resources, and specifically solar panels, and keeping the water at a certain temperature maintained if it's cool in the summertime or heated in the winter time. So that's how we maintain our system, and we have it just next to the parking lot of the campus. The other, the groundwater solar pumping in Wahat, and that was implemented the past year and this year, and you can see the students were actually implementing from the foundations to the structures to putting the panels operating and getting water from Wahat for greening the desert, a very big project. And that's the surface water solar pumping in Delta, and it's applied in Beheira on 2 locations, and it's mounting the solar panels over covered channels and sometimes in the farms, so that we can use them instead of the traditional systems. And actually, if you go there, farmers can talk to you and say, if you want to operate the system, upgrade, well, upgrade. They know the word. So it's coming to be a culture of how this can be implemented with the engineers that have been trained. And the Children University, where they have the experience of doing solar cookers and putting, monitoring the temperatures and applying them within the campus. That's a project with 25 universities, Egyptian universities. The majority are governmental universities with thousands of children involved from the age of 9 to 13, where they have the time within the campuses to implement these projects and have them on the ground. So that's preparing the young children to be part of an innovative path for implementation of solar applications, and specifically those for solar systems. Last but not least, the business incubator, which is a startup for all those who have innovative ideas, but certainly lack some technical support, some financial support, where we build a hub for these young engineers or young inventors to have support from the Yafis University, engineers and labs, workshops everywhere. So it's running, and it has every year like 2, 3, 4 new startups coming. So I guess I was long, but I wanted to emphasize that if we want to promote the idea of unconventional resources and innovative solutions, it has to start from education. It has to be linked to our research to be implemented, and then it all goes into the market and industry. We cannot go all alone. It has to be an integrated system that can support such initiatives. Thank you.
But we all know the wonderful part of these presentations is that we always see the best practice, we always see the success, we always see the wonderful things that always work. To tell us what happens when they don't work, we have Mr. Marcus to tell us what happens, what are the common mistakes. I will let you take it from here. Thank you.
Well, thank you. Hello from my side. Just before we have seen a very nice Tesla car. It has something in common with other cars. Without tires and without keys, it doesn't go. And sometimes the solar installation seems to be the same. I got all tires, it doesn't start. I got the key, but I cannot keep it rolling. So I give you a short overview about most common malfunction or the reasons for that. And this mainly is the air in the system, some general installation failures, inadequate heat medium, the sensor position, and the heat losses via circulation, insufficient heat insulation, size and positioning of expansion vessels, hot water mixing, and a missed documentation. Okay, go on to the first point. This is one of the most common reasons for failed function is we have air in the system. For those who are not so familiar with it, we have a closed loop which started from the pump which is driving the loop, pushes the heat medium via the solar collectors, gets heated up there, and comes back to a storage tank or our consumer. So, since air is able to collect itself on the highest point, if it's in water, it will block our circulation on any high point in the system, like here, or here, or here. You can imagine this in the production line. You have a transportation belt. It's going through belt. You pull on it, and someone cut it off. It doesn't work anymore. And when we start to operate the system, we have to put water into the system. And the air in the tubes will be pushed to the highest point. This is one reason. The other reason is the air suddenly appears while operation. How it comes? So we have salt gases in the water, and when I heat up the water, the gas will be heated out and collect itself at the highest point. As well, a low pressure in the system can lead to air in the system because in the night hours when the system cools down, I'm getting some under pressure if I'm already at zero pressure, and the air is sucked in to the system. So, as well, OpenSync, we have automatically working de-aeration devices. The working theory is like that. There is a valve with a floater. The water comes up, the floater rises up and closes the valve. If the water drops, the valve open and the air can bleed out. So, in a stagnation case, all storages are full. The system stops, and then the heat medium in the collector becomes steam. And steam behaves like air. It just disappears via this automatic de-aerator. So, if I'm going to install such a thing, I always connect it with a manual shut-off device. Otherwise, the heat medium disappears via steam. The pressure becomes zero, and in the night hours it cools down, the pressure decreases, and air is sucked in. And again, I have the same problems like before. Another device to ensure steady operation is an air trap. It works like lowering the speed that the air bubbles, they have time to collect themselves up to the deposit. And they are bleed out by a manual valve. So what is another reason? I did the commissioning, put the water in, and then I did a inefficient flushing of the system. I didn't get out all the air. And since automatic aerator causing sometimes more trouble than improvement, we have, by experience, we do it with a flushing device. So in the installation, I put a shut-off device, left and right side of it, two valves. With this pump, I connect the hose here, close this valve, and push the water into the system, let it pass through, pushing out all the air, bringing all the air out here. The outcoming here comes back to this vessel, and the vessel, the air has time to settle up and then push back again. And this flushing system, I leave it operating for half an hour, depends on the size of the system, until I'm sure I have no air bubbles inside anymore. So some installation failures, very common. If you have a bigger house, long pipes, you maybe mix the hot flow with the return at the point here, which means I mix a pipe, the water is pushed up to the collectors and entered at the top point of the collectors, which is against the physics, because I need to drive the loop against the thermal drive of the water. And same is here. If I get it out here at a higher point, it's not good because I'm disturbing the natural stratification of the water. So, for solar system, as a general rule, it's valid for any boiler system. The hot flow should leave at the top, and the hot flow at the consumer I put in at the top. So some natural unwanted circulation event happens. I have no non-return valve, or I have a not working non-return valve. The standard is like this. I have a pump in the system and a non-return valve. If I'm not having this valve, in the night hours, so let's say in the daily routine is the circle starts here. We store the cold water, pump it by a collector, seal it up, get it back to the storage tank. So what happens in the night hours if I have no non-return valve? Since this is more hot than the collectors are above the storage tank, the natural circulation, because the heavy cold water is pushing the light hot water up to the collector, and I have a kind of a cooling circle here. So all the energy I collected by the day hours, I get lost during the night hours. So some other installation failures, goes real quick. So wrong sealant material cannot afford the heat. I mix wrong materials like copper and galvanized steel. The heat expansion is not considered, that I have too much tension on my pipes. Collector shading, I have several rows of collectors, they're shading each other. I leave no space for insulation for the tubes. I have no flushing valves. While installation period, I get dirt into tubes, wrong center position, missing insulation, and no bleeder pipes for safety valves. The bleeder pipes is mean like this in any system, closed loop. I can get overpressure by any reason. So, for example, here in this position, I have the safety valve. I'm doing something maintenance, and in this coincidentally it opens, and the hot steam comes just to my face. So, and bleeder pipe always from the safety valve down to bottom of the catching vessel. inadequate heat medium, the heat transfer medium. Here we make usually heat medium with too many salts dissolved. Of course, it's a precondition that it's free of dirt, so I didn't write it here. And this experience, it comes that in Europe they set the standard that water for any heating loop, no matter it's a boiler or solar system, must be free of dissolved salts. This dissolved salts, if it's the first time charge, won't happen much, but it already happened. If it gets heated up, I get in limestone in the collector or in the heat creator. Could be a boiler as well as any heating loop. So untreated water can lead to channels in the absorber, and this reduces the system performance. And if I have a troublesome installation, it's always air in, always have discharge and new charge and get new water in. It will not take a long time that my collectors are jammed and the system efficiency is very low. And of course, the bigger the installation, the more important is that. Because the more water content I have, the more dissolved salt, and all this salt is heated out in the collectors. Even the sensor position, open causes failures. Whether it's on the wrong position, it doesn't sense the temperature I need to sense from my control. Or another simple reason is just wrong connected. Or boiler is broken, the contacts are broken by corrosion. Another failure what reduces my system efficiency is relosses via circulation, and this I'm not meaning now the circulation in a loop, it's a circulation in a single tube. So I have a kind of tube here, steel, copper, plastic. However, the ambient is colder than the storage temperature. So at the tube wall, the medium cools down, and because the cold medium is heavier than the hot medium, it sinks to the storage and pushes the hot medium out to the tube. This can happen that I'm losing from a storage tank over 9 hours, I'm losing 20 degrees right now. It depends. The higher this tube leads, the stronger is the effect. So I can't prevent this by a kind of thermosiphon here. This thermosiphon is not insulated, so here I have a cold area, and the water does not go down, and so I prevent this circulation. Here's a detailed drawing of this effect I just explained. At the tube walls, it goes down, turns back to the storage tank, and pushes the hot water out again. So insufficient insulation, of course, this is obviously not good. If it's just this one single point, I would not care. But actually, we should always care, because step by step I go in the wrong way and I cannot pass through the door. So one other important thing is the expansion vessel. The working theory of such a membrane expansion vessel is I have a gas chamber separated from the medium chamber with a rubber membrane. Here in the gas chamber, I have a preset pressure. This is a vessel, how it's delivered, and this is the vessel built in and ready for operation. So I have a certain water deposit in, which can compensate the heat expansion and suction from the medium. And here it's in operation, the installation, the heat medium is hot, expands due to the heat, and is pushed into the expansion vessel. So it compensates the change of volume. So what failures can happen with the expansion vessel, I just have the wrong size. size is too small, and it can even not take the expansion volume from installation. This will lead to overpressure, and the safety valve is possible. I have the wrong pressure in the gas chamber, too high or too low. What happens if the gas chamber is set with a too high pressure? The heat expansion cannot enter the expansion vessel. The pressure rises and opens the safety valve. And if the pressure is too low, during commissioning, I charge the system, and while charging the system, I even charging the expander vessel, because there is no counter pressure. So what happens the first time heat up, water is expanding, open my safety valve, and again it starts to travel through less pressure, suck in air and it goes down, and all the connected flows. So the position of the expansion vessel is very important for the lifespan and for the function as a safety device. So the connection of the expansion vessel is here with no shut-off device in between the heat source. No unauthorized person can just shut off the device, is heat up and has no chance to expand. And the position of an expansion vessel should be like that. The expansion vessel should be, the connection should be on the top side. And it's like when the system is completely heated up, even the return here becomes very hot, up to 90 degrees, it depends on the system. And if the 90 degree enters and touch the rubber membrane here, it's aging very quickly, and they have to do step-up management. Another thing is, no one did the documentation. Some part is broken, like a pump. I don't know the specifications, I don't know where's the supply, I don't know what power, and so on and so on. So this is even a very important thing for solar installations or any installation. Another thing is a hot water mixer here. This is a domestic hot water storage. I'm going to heat it up to 85 degrees, which is far too hot for a shower, but I want to use all the solar gain I can get. So I put a mixing device, and to the consumers, I limit it to 60 degrees. I have less dynamic in the storage tank and keep the stratification there. It's even more safe, especially for kids. And I have a higher possible temperature in the tank, so I can really make use of all my solar energy I get during the day. So, many information in short time, but after considering all and this experience, we are even able to make multi-loop systems, like here it's a solar cooling. This experience and time, hopefully it comes here easy. No, but sometimes, I need to say, it's just like this. Thank you.
Thank you. I think one key takeaway that we can take from this aspect is that seeing as how there are many different points of failure, many different issues that can occur, is that is the need for national quality standards for these kind of industrial type solar thermal energy systems. In this case, in order to avoid these issues, in order to create these kind of standards and steps in order to address these issues. Would you agree, or? So, now, the time as part of the schedule, we're supposed to have the coffee break, but I think we can take about 5 minutes for questions. So, does anyone have any inquiries on the presentations that came? No one has any questions? Okay then, I guess we're then free to go to the coffee break. Please come back at 12:30 so that we can continue right on time. Thank you, everyone.
Kinderwagen hierher zu bringen. Und er macht mit seiner Masterthesis jetzt eine wirtschaftlich-technische Untersuchung, wie man das angehen könnte an dieses Thema. Viele Kinderwagen in Europa werden durch bessere, effizientere ersetzt. Was machen wir da eigentlich anders? Hier sind die klimatischen Bedingungen fantastisch. Weniger Windspitzen, weniger Stürme, keine Gewitter, kein Eis, Schnee, keine Minustemperaturen. Mehr Kühlschnitte. Ideale Bedingungen oder gleiche Bedingungen für den Tag. Was machst du da genau? Was ist der Verschnitt?
Es geht nur die neuen Einspeisetarife, also die Investoren und dann immer neue Einspeisetarife, also das war und dann sagen die Investoren, ja, jetzt redet man auf einmal nur über den Einspeisetarif, haben wir jetzt ein Projekt genehmigt. Und wir haben schon durch die UVP schon fertig, wenn wir die Möglichkeit prüfen, wenn wir jetzt einen Stock von deren 3 Megawatt anmacht, der das immer Stock beliefert, dann können wir den neuen Einspeisetarif bringen und den alten und die Motivation, die Motivation. Dann bringen wir den neuen Einspeisetarif auf den alten und haben.
Das ist ja nachhaltig, oder?
Total. Und dann bauen sie die ab, die was noch nicht einmal 10 Jahre alt ist.
Das ist sehr nachhaltig.
Das ist aber in ganz Österreich, in ganz Deutschland irgendwie Anlagen herum ist, das zerlegt, ist fertig. Die müssen wir mal abholen und was machen. Und in Europa gibt es keinen Markt dafür. Jeder, der ist in Europa wurscht, aber weil ich da 15 oder 25 gerechnet, wenn sie mir nachbringen mit 25 oder 25 und da ist die neue Anlage.
Okay. Now that we have a good idea as to the concept of the solar thermal and how exactly it's been applied and the different technologies, the next session, we've made a small adjustment to the schedule. In the next session, we will have Dr. Hind Farouk, who will be telling us as to how exactly these concepts have been applied in terms of the cities, in terms of urban planning, and how it can help in terms of energy efficiency in Egypt. So please welcome Dr. Hind Farouk.
Thank you very much for the kind invitation to be with you here. And actually, I'd like to give a big thank to Brigitte and her team for technical support they gave during the training courses for our engineers. So thank you very much because it was very useful and very helpful for our team. My presentation I will talk briefly about the central unit for sustainable cities and renewable energy in the new urban communities authority in the House. Then we'll give an idea talking about the solar water heater task force activities in the ministry, the proposed solar water heater market development approach, and some real projects of solar water heaters that was installed in the social housing projects in different cities. Actually, the central unit was established by ministerial decree in August 2014. And maybe you know that NUCA is actually working on 24 new cities. And when I say new cities, I'm taking into consideration 6th of October, New Cairo, El Abur, Shrouk, all these new cities, and ending with New Aswan and Toshka. And our main target that we should planning centrally in NUCA, in the central unit, but all the implementation should be done through sub-chapters in the 24 new cities. So we have 4 sub-chapters, one located in New Tiba, and one in New Minya, and one in 15th May, and one in Burj Al Arab. Actually, we are working on 5 main pillars: energy efficiency and renewable energy, waste management, sustainable transport, water efficiency, and green construction. But I will focus today on the field of renewable energy and deeply on solar water heater. But if you want any other data about the other activities and projects, just check our website and you will find all the data about all the projects. In the field of energy efficiency and renewable energy, we are working parallel in energy efficiency, especially the lighting and converting traditional lighting to LED, and also the awareness campaign. Solar energy, mainly PV on rooftop, solar water heater, and the district PV system. And for the street lighting, mainly we are working replacement of LED of traditional or sodium lamp to LED, and also using LED with PV central station. And I will show you quickly some pictures for our project. For example, for the LED, we already have, let's say, a decree that all the new construction in the 24 new cities will be installed by LED. For example, this is the number that have been installed in six new cities that was replaced, and this was short buildings, 2, 3 floors, but this is actually more than 9 floor building, and we have two issues here. We have the energy efficiency and PV station, and also we have grey water recycling at the same building as a model for the local building. Each one of these stations, we should have this table, summarized table